this particular problem. Yes, you can do axial diagram, you can create an axial diagram, or you can cut it segment by segment. So in this case, I will try to do it using an axial diagram. So an axial diagram really is, so I will just assume that this is my entire segment. So I will draw my diagram based from here. So based from this one, so since this is, can you, based on the loading of this, based on the loading on the structure, can you, based on the loading on the structure, is the loading balanced or no?
Yes, sir.
Dili, because summations, when you take summations of forces, horizontal, to the left it is 5p, but on the right it's only 1p. So therefore there is an imbalance moment. No, there is an imbalance of force of 4p. So we can go it like this. So that is, when you take summation of forces, horizontal is equals to 0, what you can do is, pila ni siya, we have 5p is equals, no, we have 5p minus 5p going to the left, and then p is equals to 0. So we have, this is what we call, no, sayop. This is our fx. So let's write it as fx. So if taking summation forces horizontal, so fx plus p is equals to 3p plus 2p. So we have fx is equals to 5p minus p, therefore our fx is 4p. So therefore this is 4p. So from fx, since this one is in compression, is the fx in compression or in tension?
Compression, sir.
Compression. So the fx compression. So from this point, we go by negative 4p. Actually, this kind of technique is axial diagram is dali ra kayo ninyong what we call this one, makatunan when we go to shear moment diagram, because basically same sa bitang pamaagi. So in this case, we start with 4p. So this is my point P. From 0, the part of the diagram is this is assume that kaling black na ang akong kaling black line is what you call the x-axis, and we have a 4p, which is this one is in compression, so I go down by 4p, and then so this one is now 4p. So this is 4p. So from point A, this is point A, this is point this. So this is point A, this is point B, this is point C, and this is point D. So from point A to point B, do we have an additional loading or wala? Kato nga steel.
Wala, sir.
Wala. Between point A to point B, just before point B, wala tayo additional loading. Therefore, our loading there is consistent. That is negative 4p. Ito lang siyang alisdan of color nga, ito nga color, pink, green na lang. So, para so this is still 4p. And then this is also 4p because there is no change in loading. But at point B to point C, do we have now a change in loading? At point B, na ba tayo change of loading? Low class na ata, because at point B na atay negative 3p, and atay 3p that is going to the left. Tama? So we have, so minus 4p minus negative 3p, pila man na siya karon?
Negative 1.
So So negative 4p, no, we are already at this point. We are already at point B. So between point A to point B, the force is consistent. That is negative 4p. But at point B, we have a load of 3p. So negative 4p minus negative 3p. Anong minus negative 3p man? Because 3p is compression. It is a compressive force. So minus that it becomes a positive. So negative 4p. No, it's not negative 7. It's negative 1p because negative 4p minus 3p, so minus 3p, that becomes a positive. So negative 4p plus 3p, so that becomes negative 1p. So this one becomes 1p, negative p. So that becomes a negative b. So between b and c, do we have an additional loading? Wala natin additional loading just before c. So it is still consistent. This is still negative p. Actually, it takes a practice to do it, but once you understood the concept behind this one, so actually dali na lang kayo ni siya rather than katong mag-cut mo or mag-segment. But if you really are having time doing this one, then I don't have a problem when you, if ang yung style is when you do it, when you cut the segment. So from negative p, we have negative p minus negative 2p. So pila may magawas?
1p.
So that becomes 1p. So this is a 1p. And then from there, pala na pang load because at the end, we have to come up that the loading is p. So but at the end, so the loading is just p. So nagbalance sa ato ang system. So ni-balance sa ato ang system. Ako siya. So manang salutang siya. So this is positive p. So that's one. So this is now your axial diagram. This is what you call an axial diagram. So how do you interpret your axial diagram? How do you interpret your axial diagram? So from the axial diagram, we can conclude that P bronze, what is the force of our steel? What is the force of our steel? Steel. Between A to B, that is a steel. So we can say that the force of our steel is negative 4P. The force for our aluminum, how much is the force of it in our aluminum? Negative P. But then, the force in our bronze is pila? P. So, then we have already calculated the forces in steel, aluminum, and bronze. Now we are ready to substitute. So, find the maximum value of P that will not express. So, we are given conditions. So, what are the conditions? So, the forces in our bronze, and the forces in our steel, aluminum, and bronze. So, steel, aluminum, and bronze is only limited to 120 MPa and then 80 MPa and also 90 MPa. So we are to calculate the maximum force speed that will not exceed any of the stresses here in Gravitas. But what is our modulus of elasticity for steel? That is Pilani. It is 29,000 psi. So we have to convert it into aluminum. So I check your papers and I think you already know how to do it. So pila ganitong aluminum? to class, it is 29,000 psi, 29,000 psi. So pila siya ang equivalent niya sa imong steel. Could you please check? Di na lang ko siya i-convert dire because I checked your papers and then murag sakto man ang inyong conversion. So this must be close to pila man ang modulus of elasticity of steel in SI unit. Pinabista?
So, sir?
Pila ang modulus of elasticity sa steel in the SI unit?
Oh, 1 MPa.
Yes, in MPa. Pila?
Wala, nagyang.
Kasi ako compute.
No, that is 200,000 MPa. So when you convert this 100, when you convert this 29,000 times 10 to the 6 psi, it has to be close to 200,000 MPa. So pila ang inyong answer direct class? So give me the numbers.
199,947.953, sir. 947.953.
953. This is psi, pounds per inch squared. That's psi. P that stands for pounds. The S means square inch. So pounds per square inch. That is psi. So this one is correct. No, this is not psi anymore because the given is psi. So this is in MPa anymore. NPa, that is Newton per mm squared. So again, the standard modulus of elasticity of steel is 200,000 MPa. But since ang inyong nakuha nga modulus of elasticity by converting is 199.9 MPa, so I think this is already a good value. So I think munang nakaingon ko nga your conversion is correct. So pila ni? How about for aluminum? Give me the numbers. 10 times 10 to the 6. So that is 68,947. What is that? 53573. Newton per mm squared, or pwede na pulog MPa diretso. And then for bronze, ila sa bronze? Class pila itong bronze? 99,
973.
973,
0.9765.
976 Newton per mm squared. So don't worry if kalailain mo point karang dapita because it will really not change the answer significantly. So and kabalo sad ko mo check ana if so don't worry agad when you do your conversions if dili mo parehag answer so right problema. So we are now asked to find the maximum value of P. So from unsa ganito, when we evaluate the stress, what is the stress gani? Stress is force over area. Tama? Hello?
Yes, sir.
Yes, sir. So force over area. So now the force over area. So we are now ready to calculate for the forces in bronze, in steel rather, steel sata. So with that should be stress in steel times what? Say stress in steel times what? Area in steel. So what is the stress in steel? It is limited only to 120 Newton per mm squared. But then, your area sa steel is we are given with 500. Tama ba? We are given with 500 mm squared. Actually, bason ma-board na mo ani because this is just a very easy example. But please bear with me because pasunyag namon sayop later. So, cancels out. So, pila ang answer sa atong PST. Class, pila ang answer sa PST? Ha?
Negative 4p pa man sir, no?
PST sa?
Sir, di ba naman 4P, sir, no?
60,000, sir.
Still pa ta, still. Dili pa 4P. So, dili pa man. On the force in steel pa man. Pila na? 115,000?
60,000 na, sir.
60,000, sir.
60 or 15,000?
15 kilonewton, sir.
Ha?
15 kilonewton.
1.5 kilonewton? Sakto? Sa uban?
60,000, sir.
60,000 or 15?
60,000.
Wala na magikuha ng 4, sir. Katong 4P, sir. Munang 15 ang yung answer. Kaya mag-include ng 4.
Ha?
60,000.
60,000 sir.
Okay, 60,000. Napatay 4. Tama?
Yes sir.
Yes, sir. Divide by 4.
60,000 ni kaning 120 times 500 this is 60,000.
Yes, sir.
Yes, sir.
So this is 60,000 Newton. But then our PST is just equal to, when you try to look at this one, our PST is, from this one, we can say that our PST is equal to 4P. So our value of P is, this is negative 4, but the negative sign is just an indication that it is a compression. So, pila man na siya. So, P is equals to negative 15,000 Newton. Okay, so ayos sa ninyo gidiretso kuan because we'll try to do it kanang mais-maison ba para masabtan sa tanan ba. So ayos ako ninyo katagig final answer. So okay, so this 4P is this gikan na siya diri nga equation. Kani kanang naay arrow. Okay? Sabtan na ba sa tanan?
Kulang na mo sa kasiro, sir.
Ay, 6,000 na diri. Okay. This one. But then for P aluminum is what? Stress in aluminum times the area in aluminum. So what is the stress in aluminum? What is the limiting stress in our aluminum? It's 80,000. No, 80 MPa rather, not 80,000. And the area is 350 mm squared. So this one cancels out. So PAL, pila tong PAL?
28,000, sir. 28,000,
28,000
sir.
Newton, but then PAL is just equal to negative P. So P is equals to negative 28,000 Newton. So I hope you can easily follow that one. So and then P bronze is equals to step bronze times the area in bronze. So pila may stress atong bronze is, I think it's 90. 90, yeah, it's 90 Newton per mm squared. And what is the area of our bronze? It's just 150 mm squared. So the mm squared cancels. So what's left is Newton. P bronze is pila?
13,500.
13,500 newtons is equals to P. Therefore, so without therefore, because the question asked for what is the maximum value of P. So you have to answer that one. So what is now the maximum value of P? So P max is equals to what? 13,500 newton. So this is the answer for the first question. Nakuha ba ni sa tanan? Sir. Yes, sir.
Yes, sir.
Yes. Question.
Yes, sir.
Yes, Bunjo.
Yes, sir.
Ang sali ay? Now, the second question is, compute the total change in length of the bar No, we are now able to compute the total change in length in the bar. So, compute the total change in length of the bar. So, what is now the total change in length of the bar? That is the elongation or shortening of steel plus the elongation or shortening of aluminum plus the elongation of shortening of what? Of bronze. So I think during the pita is dagang nasayop. Actually, one of that nasayop is si tubak. So murag diri siya usa siya sa mga nasayop during the pita. So dapat dili mo masayop during the pita. So here, so the total change. So what is this? The total change. So what is the force? So ano na siya? So PL over AE. This is just for steel, and then this is for ako lang gimais-mais gyud niya kay para so you don't have to do it sa exam, but I am just showing it para sa uban nga medyo naglibog pagyapon. So total. So what is the force in steel? So PS. So we know that PS is equal to 4P. Tama? We know that PS is just equivalent to 4P. We already have that relationship. So but what P are we going to use? Because sa katubak na calculation, he used the P which is 1,000, which is 15,000 Newton. Is that correct?
No, sir. Maximum.
Yes.
Yeah, you have to use the maximum P because if you use this P which is 15,000 Newton, then the chances are in this case your bronze will be exceeded, and when your bronze will be exceeded, your stress in bronze will exceed with 90. So sayop tong iyang gibuhat. So you have to use the formula here. So PS is just equal to negative 4P. So we have 4, but RP is just 13,500. And pila tong L is 3. Let me show you the units na lang. Ayan na lang. So 3,000. And then A, what is the area? 100. And then what is the E? The E is 199,947.953. 199,947.953. So plus, how about for aluminum? Aluminum is, or from relationship here, our aluminum is just equal to negative P. So our aluminum is negative 13,500. So what is the length of our aluminum? It's 2,000. And then our area is 350, but our modulus of elasticity is 68,947.53. 68,947.753. Is it correct? 573 rather. It's 573. And then the other one is for bronze is just 13,500. What is the length of our bronze? It's I think 1,000. It's 1 meter, so it's just 1,000 over 150. Is it 150? Yeah, correct. It's 150 times, what is the modulus of elasticity? 99,973. 99,973. 0.976. So could you please try to evaluate this one, class? So pila ay answer.
Negative 1.839.
Negative 1.839 mm. So this is the final answer for question number 3. Now, if I am going to if I am going to make a variation of this question, what do you think kung unsa akong buhaton ani? What are the possible variations nga may tabuan nga question? Probably you are given still kanang limiting stresses, and then probably one of the you are probably the total elongation for AB, BC, and CD is probably just limited to, let's say, the answer is here is 1.83, but it's probably just 0.5 mm. So what is now the maximum value of P if the total change in length of the whole bar is just reduced to 0.5? So that's one possible variation nga inyong una-unaon if, for example, nana siya. So that's how you think nga kanang, because yes, I get exams from the books, but you know that I don't exactly copy yung unsa nga nasa book. I try to change some portions of it. So I include probably there's so many variations. So one of the variations ang akong giingon is probably the given here is the total change in length. So how do you compute the maximum force P here if the total change in length is given? Nana, also given sa ang limiting stresses. So you have 4 conditions to check. One condition is if the stresses that dapat dili mo exceed aning tulo ka stresses nga given. And then another condition nga gihatag is the total change in length of the whole system must not exceed a certain number. So pila may maximum value of P. So in that case, if the total change in length of the whole system is reduced, dapat the maximum total change in length of the whole system is just changed to, let's say, 1 mm. So what do you expect in the value of P? Will it increase or will it decrease? Hans, Jasper Belonghilot. Hans Jasper.
Sir?
Yes. Did you hear me or wala ka namin now?
Wala, sir. Kiso ko.
No, forget about it. So, Jennifer, did you hear me or did you listen to me?
Yes, sir. Yes, sir.
So if the total change in length here is negative 1.839, and then I say, probably in one of my questions says that the total change in length of this bar is just limited to 1 mm. So, and then you are to compute the maximum value of P. So, what do you expect in the value of P here, the 13,500? Is it going to increase or is it going to decrease?
I think it's going to
Mas dako ba nga P ang akong makuha? If what? So you have to imagine that, class, so that when paggawa sa inyong final answers, you will be able to interpret it whether your solution makes sense or not. Ano ba? So anyway, forget about it. I'm just telling you that the one possible variation of the problem. And then another possible variation of the problem is that I could probably just give you the diameter of the sections and then you compute for the area. Or probably I can give you, if this bar is not cylindrical, probably the bar is made of probably a flat bar or an angle bar. You will be able to calculate the area in that case. Or there's so many variations of this problem. So just think about that one. For example, if I change one bar here, for example, the bronze, since if I change the bronze from a cylindrical to I change it into an angle bar, what is now the effect in the maximum P that I will be able to get from that one? So try to, probably if mag-study mo is try to think of so many variations aning akong assignment because yes, I'm giving you already the topic na my quiz number 3 is just revolving around this one assignment number 3. So, but in a different variation. So, any questions? Yes.
Sa pag-exam ni mo, sir, inatarag yapon ang type of question pero may
Yes,
variation.
may nanaragyan siya. So probably instead of you calculate the total change in length, probably it is restricted that the change in length in aluminum is 1 mm. Probably something like that. So what is now the total change in length? If I restrict it that the change in length in aluminum is just 1 mm. So what happens now to the change in length to steel and the bronze? So you have to make a correlation on the changes between the so something like that. So don't just study or don't just think nga murag yun siya because there's so many possible changes in yung question. So and anyway, so let's have example number 2. So let's have example number 2. So this is also from your one. If wala na question, let me proceed to example number 2. So wala na question. So try to work on man lang yun. Ito siya nga kanina. So the rigid bar attached to vertical rods as shown is horizontal before the load P is applied. So determine the vertical movement point of point D if the magnitude of P is 75. So actually dagang nakakuha aning number 1 but there is a number 2 nga question is dagang pong sayo. So let me introduce to you how is this problem unsaon ang the right solution aning nga problem. So you're given a system no? So from what I can kabalo na mo ana, so that is the system. So from here, you take the free body diagram. So I am now drawing the free body diagram. So this is my aluminum. This is my aluminum. And then this is my PF steel. And then I have 75 kilonewton force here. And then this one, so this one is natay 5 meters. Pila ang total ano niya? So this one is so if this one is 5 meters, so if the total from point A, let me put that. This is point A, this is point D, this is point B, and then this is point C. So this is 3.5 meters. Pila na lang ni? Kaning usa from between D to B. I think this is 1.5 meters.
1.5, sir.
Correct. I think 1.5 meters. And then B to C, it's 3.5 meters. So this is 1. So when we take summation of moments at point A, summation of moment at point A is equals to 0, what do we have? We have 5 times 75. Let's start with 8.5 times P is equals to 75 times 5. Tama ba?
Yes, sir.
So, pila tong P?
118.
44.118 kilonewton. So if we take summation of forces vertical is equals to 0, what do we have? So P aluminum plus P steel is equals to 75 kilonewton. So P, yes. So pila man ang atong P aluminum piece of steel. So this is one of the equation that we can have. P 8.5, now this is PST. This is not P. PST, this is PST. Tama?
Yes, sir.
Ayun sa nato right camera. Pangit. So this is 8.5 PST is equals to 5 times 75. So PST is equals to pila? To
44.
44.118
118.
kilonewtons. So P aluminum is just 75 kilonewtons minus 44.118 kilonewtons. This is equals to
30.882.
30.82.
ha?
30.882.
30.882 kilonewtons. So from here, we can now calculate our deflection. So calculate deformation. Calculate the deformation. So what is the deformation of our aluminum? That is PL over AE, and this is just for aluminum. So what is P in our aluminum? We have calculated it to be 30.882 times 1,000, because I changed it into from kilonewtons to newtons. And then what is the length of my bar on aluminum? That is 3 meters. So that is 3,000. What is my area for aluminum? Pila ganini? 500 mm squared.
600.
Times 500, 600. I think it's 500. 500, sir. 500 times modulus of elasticity of aluminum is 70 GPa. So that is 70,000 MPa. So pila ni sa class?
2.65.
2.647
2.647.
647.
467 mm. Ito siyang i-move to repeat kay marag doon kayo sa
2.647.
647, sir.
647, not 467. Okay. 647 mm. So how about for steel? So PL over AE. So this is mura gini ang formula nga inyong gina-memorize. So bigyan mo kayo mo matuok sa formula because that is 44.118 times 1,000 times the length in steel, that is 4 meters. And then the area of steel is 300. And then 200,000. So pila ni siya? So
2.941.
2.941 mm.
pila?
941, sir.
So 941 mm. So try to put class, try to interpret your results. So does this make sense? Does the change in elongation in my aluminum is 2.647 and then steel is 2.941? Probably made sense. But pag makakuha ganin mo o deflection nga, because sa inyo ang magod is o kung saan mo gawas sa calculator, automatic na dahil mong sulat. So base mo gawas is 2,647 mm. So that's a very big deflection. So that doesn't make sense anymore. So imagine mag-deflection ka 2 meters. Try to kuan lang po ba? Because some of you man is automatic ra na. Kung sa'yo mo gawa sa calcu is automatic sulat, and then you don't try to hindi mo tanawon if the solution makes sense or if the result makes sense or dili. Basta kay makakuan lang. So what happens in this case? Because of this forces in steel, what will happen to your aluminum is that it will elongate up to a portion here, and then also your steel will be Kasi mas taas. So, mas taas ang imong 2.941. So, mas taas ang elongation sa imong nga steel. So, mas ni ana imong steel. So, this is just an exaggeration. So, we are now, so this is just an exaggeration. So, this is the deflection in aluminum, and then this is your deflection in steel. So, we are to calculate the deflection around this point. So this one. So what is that? So this is delta D. So how do you calculate this one? You can have it using ratio and proportion. Actually, daghan kayo mong correct during the pita. So I think this is just a very easy one. So this is, let me just introduce this one. So this is between this one to this one, kanisa, I will just label it as y. So that when I do ratio and proportion is I have one, because the total deflection at point D is just the deflection in aluminum plus y. Tama ba?
Yes, sir.
Correct. So the total deflection at D is just the deflection aluminum plus your y. So but what is now your deflection at y? So we can do ratio and proportion in this case. So how do we do ratio and proportion? So pila ST delta ST minus delta aluminum all over 8.5 is equals to 3.5, no, y 3.5. This one plus, so this one, this is just kanilang sa itong ratio and proportion. I'm taking a ratio and proportion in this very big triangle. Pura kayo siya.
Honduras, kabikang
I'm taking ratio and proportion in this big triangle and this small triangle. So, I think that's one. So, ano ako mang-minus ang ST minus aluminum, because this I'm just only concerned of this height. I am only concerned of this height lang. But pila man na siya. So, that is this one. Deflection in steel minus deflection in aluminum, and the total change in height. Now, give me what is now the value of y.
0.121.
0.121 mm.
1 to 1 mm. So therefore, the change in length in D is ilatong sa aluminum, it is 2.647 mm plus 0.121 mm. So this is
2.768 mm.
2.768 mm, sir.
2.768 mm. Okay. So this is the final answer for this one. Now, class, can you spot the word there? There is a question. Can you spot the word there that makes the solution correct? If I omit one word there, this solution will no longer be correct. Meaning to say that if I delete that one particular word from the question, this solution will no longer be true or this solution will no longer be correct. Can you spot that word that makes this solution correct? Densil, from the question, the rigid bar attached to two vertical rods as shown is horizontal before the load P is applied. Based on that one, there's a particular word that makes this solution correct, but if I omit that one word, this solution will no longer make sense. Can you spot that, Densil?
Horizontal, sir.
Horizontal. That's also correct, but there's this one. The correct answer is actually rigid. The correct answer is rigid bar. The rigid bar, meaning to say that the bar is rigid between A, B, and C. Tama? So what happens, or what is now an implication that when you say that the bar is rigid, what happens to your bar? Does your bar change in length? No. Or no?
No.
So since
No,
your
sir.
bar does not change in length, so there should be, you can have a ratio and proportion during the pita sa imong one. Because if your bar is not rigid, what happens to your bar? Because you loaded at point P, what happens to your bar at if your bar, if your ABC, if your bar ABC is not rigid, what will happen to your bar?
Mabend, sir.
Mabend. That's why that the introduction of the word rigid here makes the solution correct, because if there is no word rigid here, this solution is not correct, because of the application of the word, or because of the application of the load, if this bar is not rigid, you will have some kind of deflection. In anang may tabo sa imong deflection. You will have something like this. You will have a deflection during the pita, and then you will not be able to do ratio and proportion, because the deflection right there is no longer linear, it is parabolic. But because of the introduction of the word rigid, meaning to say your bar does not change in length, your bar does not bend, that's why you can do ratio and proportion, because this is now, kaning blue, kabante mo ning blue, this is now the final style. This blue right here is now the final location of your bar when you try to apply the load. So, okay, so that's why kanang load is just linear, because wala na siya nag-bend. So can you on that one, class? Now, let me introduce to you entire screen, share now. So can you see what's on my screen, class?
Yes, sir.
So this is the bar. So this is one is the aluminum. This one is the steel. So this is the rigid bar. So I've modeled it in STAAD. So I'm using STAAD as analysis software here. So I'm using STAAD. So let me check my loading. If I load here 75, yes, I load 75 kilonewton here, and then let's try to imagine what happens to the system by loading 75 kilonewton. Well, this is now the result. So see, from what you can see, this is what really happens to your bar. So we are here at point 1. Can you see? Can you see one? Can you see that one? This the point here. This is number 2. The one of my cursor. Hello. Can you call class? The green one is the deflection. This is what the deflection of your structure. Mauni ang may tabo sa inyong structure because of the loading at 75 kilonewton. Can you see it, class?
Yes, sir.
Yes, sir.
This one. So let's try to check if the results of the analysis software is indeed correct. So this one, the node number 1 is the pin support, and the point also is pin support that is similar to what is our problem. So let's check our displacement. So here is the vertical. This is point 1. This is node 1. Can you see? Kaning asa dapit ang akong cursor? Kaning green? Kaning may black?
Yes, sir.
So can you see?
Yes, sir.
So the vertical, that is the vertical displacement. We have horizontal displacement. We have 0 because there is no application of horizontal forces. So we have 0 in horizontal and then 0 in vertical. Why do you think? This is at node point. Node point. The number 1, kanisha. Why do you think 0 ang atong displacement nilang dapita? Hello?
Wait, pin develop, sir.
Yes, because this is the point of support. This is what you call the boundary condition or the support condition. In this case, I apply a pin support. Now, a pin support or a fixed support does not allow your structure to move. or does not allow your structures to move. So when you apply a pin there, so that means that is your support, that is dili yun na siya move. So that's why there is no deflection. Now let's move to point 2. Can you see the point 2 here, this one?
Yes, sir.
This is node 2, and the vertical deflection as node 2 is 2.647. Does it match with our calculated value? The deflection of aluminum is 2.647 mm. Does it match sa kanina nga previously calculated na to?
Yes, sir.
I think it does. And then the 0.5, this is the 0.5, this one. Can you see it? The 5. So this is number 5. So we check number 5. So the deflection at number 5 is 2.941. Is it the same with the deflections we get from steel?
Yes, sir.
Yes, sir.
So that is also correct. And then there is a number, this is number 4 is the point of the application of load. And then number 3 is our point E. So the answer is 2.769. So pila to nga itong na-compute kanina?
2.768, sir.
So very, very close. So see, the results of the software here is actually similar to what we want. So meaning to say that we can use this software because we've already tested its capacity that it will really yield the same answer if we do a manual calculation. So there's so that's mo lang niya akong ganang ipakita ninyo nga this is the software. So now let's try to change some part of the model because when we look at the materials, this one is the material is rigid. I make this one the rigid material. This one, the rigid. How about if I change it to aluminum? So if I change this one, the rigid, the bar ABC to the same material as a steel, meaning to say this is no longer rigid, what do you expect in your system class? So unsay may tabo? Properties, let's change this one. Let's change this to steel. No. Assign this one to steel. So we have now two steel. This one is aluminum, kanang naka-red, and then steel. So I make this one steel katong vertical and then the horizontal is steel. So before this section right here kanang naka-red, before in the previous problem this section right here is a rigid. That is supposed to be a rigid bar, but since I changed its property to a steel rather than a rigid, so let's try to run another analysis and let's see what we can get. So post-processing, let's go to results, displacement. No, this is now the deflection of your structure. So can you see that when you change the material from the rigid bar into a more flexible material, you will now have a different deflection. So that's just what I am trying to tell you. When you say you really have to check the problem, the wording yun sa pagkuhan ang problem because that is really a big part on how you will do your solution. So try to look at that one. So this is now kaning the green. This is how your structure will deflect if this bar ABC kanina is no longer rigid. So I changed the material from rigid to steel and this is now the deformation of my structure. So I'm just trying to introduce to you the concept of unsay may tabo sa ato nga structure. Now let's look at the shear and moment diagram. Now if you draw the shear and moment diagram, so this is how your shear and moment diagram would look like. So in the next chapter, or in chapter 4, which is our discussion on Saturday, we will be discussing about shear and moment diagram. So let's try to see if we will be able to get the same shear and moment diagram as also what is this software is presenting to us. Okay, so any questions relating to these softwares? So when you do your analysis or when you do your designs, you will be using structures because when you do your design, especially let me give you an example. This is a design, but let me just go on. So this is part of the design. me orient you. So this is one of the designs that I created for the dormitory project in what do you call that one, in Bayawan. So this is one of the designs I created. So I used STAAD to do the analysis for that one, and because this structure is already complicated, so you have to do software to do it. So from when you do post processing, you will be able to what is now the effect of your structure. So in this case, let's try to find that one with deflection. So earthquake, let's introduce. Let's try to add earthquake load. So what will happen to your structure if we introduce a lateral load? So lateral load is asa man turo nawala. Animation, deflection. So that will happen. That is the simulation of your structure. When you apply an earthquake load, that is going to be the response of your structure. So I'm just introducing to you. Although dili mo maginani, but I'm just letting you know nga there's so many variations sa problem now. In this case, as you can see, this one here, this one, this is a fixed support, but the other one is a pin support. So my idea here is that I don't want any moment that will transfer to my foundation. That's why I put pin support, and then the other side I just put fixed support, because I want all the moments that is coming from the earthquake will be transferred to these foundations, because this will be Moni ang mga dagko nga foundations nga kuha nga i-design. So that's just something like that. So I hope this gives you an idea of what to expect when you do building design, something like that, because you will always be doing something like this. And although in building design, I will not allow you to use software, and in fact, I will only allow you to do manual calculation. So I am introducing to you, I'm letting you know that what will be the effect of your structure when you apply this kind of load, this kind of boundary condition, this kind of support, para na amoy idea. But anyway, that's it. So kani siya nga structure is already gitukod na ni siya karon sa Bayawan. So questions? So I think na ko'y example ana, para at least nagin mo yung idea, good ba? Asa na siya karon. So sige lang ka. Okay pa, wala pa man dagay gigutong tanan. Madala pa kuan. Madala pa class. Kuan lang yun. Kuan lang sa because I am Madunggan pa ko?
Yes, sir.
Yes, sir.
Oo. So, kaya pa ba natong kuan? Padayon pa batas, because we still have one problem. So now, let's proceed to another problem. So if wala na questions aning number 2, then let's proceed to another problem. I know, wala pa nato na answer ning P. There's also a sub-question here. So if the axial stress of aluminum and steel is limited to 145 and 275 MPa, so what are the conditions? We have already given conditions na sad. So we always have to check the conditions, because probably that condition is munang condition sa site. Probably munang natay mga conditions is probably kanisa diri munay maximum capacity lang sa imong steel. So how are you going to adjust the sizing of your area? How are you going to adjust the forces, or nana lang? What's that to? The question is, the change, pila man ang atong force nga P. So the conditions are, bagara kayo siya.
Sir, wala pa ka percent, sir.
Ay, wala pa ako ka-percent. Ganun. So we will be doing more of atong presentation ako ganina sa STAAD when we do shared moment diagram, para mas ma-appreciate ninyo nga kung sa effect sa shared moment diagram sa inyo nga structure. So sa itong mga conditions, so the aluminum and steel is limited only to 145, and so 145 MPa, and for the steel it's 275 MPa. So how are you going to do it, class? So when you check your conditions, kung sa ganito, PEL is equals to stress in aluminum times the area in aluminum. So, pila man, PAL, stress in aluminum is 145 newtons per mm squared. And then your area in aluminum is 500 mm squared. So, 500 mm squared. So, cancel this one. So, pila mong AL, PAL, force in aluminum.
72,500, sir.
72,500
500.
Newton. But we have already calculated here that may PAL, yes, 72,500. Is it? But ang atong nakuha ganina is only 30,883. Now, how about for steel? Pila area sa itong steel class?
300, sir.
300. 300, sir.
300, sir.
Stress sa steel times area sa steel. So stress sa steel is 275 Newton per mm squared, and then 300 mm squared. So pila man eh?
82,500, sir.
82,500 Newton. So, kung saan nyo pag-answer ng question number B, if the actual stress of aluminum is limited to 145 MPa and 275 respectively, how much load must be added or subtracted to P to maintain a safe working system? Given this one. So, based from this one, let's copy this one because this is now your system. So let's change this one from 75 kilonewton to P. So ang gibuhat sa uban is they adjust this 72,500 plus 82,500 minus 75. Ang gibuhat sa uban is P is just equals to 72,500 plus 82,500 minus 75,000. Is it correct? Pila ni? I think muna yung gibuhat ni 80,000. I think muna yung gibuhat ni Bonjo. 80,000 Newton. Is this correct? Sakto ba rin siya, guys? This is a very obvious na wrong na answer. So what we can do is we can take summation of moments at point A is equals to 0. So we will have pila man eh. So PST, that is 8.5 PST is equals to 8.5 PST is equals to pila ni class? 5P. 5P. Therefore, P is equals to what? 8.5 over 5 PST. So, pila ni? So, we have PST. Pila gani ang PST?
82.
Yes. 8.5 over 5 times PST. 82,500. So, P is equals to
140 to 50.
140 250 Newton. So that is when we use the steel. But how about if using aluminum? So we change forces vertical is equals to 0. We have PAL plus PST is equals to P. So our P is kanisha, so we will be able to get PAL. So 140250 minus PST. Pila PST? Pila kas PST?
82,500. 82,500.
PST is 82,500. So, pila yung mga aluminum nga force?
57.
7,750.
50,000 sa 57,000. Pila?
750.
750. Ano? Save ko ah. Save. Na medyo nalipat ko sa problem. Let me just delete this one. So I will just express my PST in terms of P. So PST is equals to 5 over 8.5 P. So pila ni? Can you please evaluate this in fraction more like 10 over 17?
16 over
5
17.
over 8. 16 over 17. Sure, 16? 16 over 17.
Ay, 10 over 17 ay sir 5 ba eh?
Gani, 10 over. And then take summation of forces. This is equation 1. And then taking summation of forces vertical is equals to 0. So we have PAL plus PST is equals to P. So my PAL is just equals to P minus 10 over 17P. So this is probably 7 over 17P. Tama ba? Seven over 17P ba? Plus, tama ba? 1 minus 10 over 17.
Yes sir.
Hello?
7 over 17.
Yes, sir.
So let's move the solution right here. Ako na siyang i-rearrange ang mga ang solution na para ayra mo kapahan. So pila value when we try to evaluate the conditions, so this one we know that PAL is just 7 over 17P is equals to 7 over 17P. So pila tong value sa tong P? We've already calculated it before. So this one, para masayun sabtan, is from this one. So PAL man eh, just equals 72,500. So pila nga tong P class? So P is equals to 72,500 times 17 divided by P. Mas pila siya? I think murag mo tutong ganina katong pila ni? 170. 72,500 times 17 divided by 7.
176,071.
176,071 point pila?
429.
43? 429? 429. 429 Newton. So how about for this one? PST is just equals to 10 over 17P. So this one, this 10 over 17P is from this one. So pila tong P?
One.
140 to 50 sir. 140 to 50 sir. 140,250.
140,250 Newton. So what is now the maximum value of P? Therefore, max P is equals to pila? Between this one,
140.
176 or 140, so it should be 140 to 500 newtons. So, mas dako ba ni siya sa 75,000 or mas gamay? Obviously, mas dako siya. So, pilang atong i-add. So, the change in P is just equals to 140,250 minus 75,000. So, pila ni?
65 to 50.
65,000 to 50.
250 newtons. So, this is the answer to sub-problem number 2. So, this one. So, just try to review this one of yun sa siya because that is the answer for problem 2. So, did you get this one? Abay nakakuha gin ani? Kay murag ka dinsel isayo ka kuan pod ka bonjo isayo gyapon. So sayop, so try to kuan lang siya nganong asa mo nga part na sayop sa iyong solution because there's really this is another kind of variation sa iyong problem. Another variation for this problem is probably at this point A, probably point A, can you see the bar there? So probably one question there is given the bearing stress and given the shearing stress, you have to compute how many diameter of rivets are you going to need para ma-attach ni siyang aluminum and your rigid bar. So that's another that's also another possible nga pwedeng ma-ask sa problem. And then another possible is pilay compute the change in length sa imong aluminum such that ang stress sa imong steel and aluminum will be the same, something in ana. So you are to recompute or what is the location of your P, diba? There is a location, it's already 5 meters. So another variation for this problem, from what I can see, is try to locate P such that the deflection in A and such that the deflection in C is twice the deflection in A, something like that. So you are to locate the position of your P such that madouble ang imong deflection sa steel as compared sa deflection sa imong aluminum. So mga something in ana ba. So if you try to evaluate as many, because when you try to solve problem, don't just kanang stop ug unsay naa sa libro. Try to imagine unsay mga possible variations sa iyan. What's the effect sa imong nga system. So let's have one because alas 8 na, hapit na alas 9. Sana is the problem. So may gani daghan ang nitunga karon because if wala kayo nitunga tong uban, then I would really give an exam. So this one. So the bars ABC are supported by pins at A and C and are 2 rods. So that I mean the maximum force P that can be applied in the vertical movement if D is limited to kuan. I think because kani siya nga style sa problem is naara man siya sa libro, so I expect nga daghan kayong nakakuha anis. I think murag everybody got this problem correctly. So one variation of this problem is, what do you think, class? What could be one variation sa imong problem? So I will no longer solve this in detail because naara man siya sa libro katong solutions manual ninyo how to do it manually, and of course sa inyong assignment is also correct sa ninyong solution sa ato. Kanilang yung first to mo ang akong specifically would really want to introduce because naay mga concept na medyo dito muna sa iyo. But in this case, I think sa ilang isa I would just like to introduce unsay mga possible variations ani. One of the possible variation I can see is dili in ani ang imong, instead nga in ani ang imong horizontal, probably your bar right here that is supporting this one is what? So it's probably could be something like that. So you are to determine the deflection at point D. So instead nga vertical ang imong bar, it is connected to BD, so it's probably your bar, your steel is connected from B to E. So in this case, how are you going to deal with the deflection in this case? Class, if that's the kind of problem that I give you, so how would you deal with the with the deflection in ani? So obviously, nakakay deflection during the pita. So I will just draw the deflection diagram para you will have an idea of how to do it. Because when you have an idea of how the deflection diagram looks like, then you will be able to do it. So, your bar will deflect into something like this, di ba? Because of the force P during the pita, because of the force P during the pita, there will be some kind of deflection. Your aluminum will experience tension, tama? Your aluminum will experience tension, and because of that, your aluminum is and since your aluminum is experiencing tension, then therefore there should be a deflection, or there should be a deformation, or there should be an elongation of your aluminum, and because of that, there's from this point nidaog ang imong this point because of the elongation. So because of the elongation sa imong aluminum, so this is how your deflection would look like. So this is now the deflection sa imong aluminum. So by relation proportion, you will be able to calculate this deflection. Tama? Deflection at point B. Hello?
Yes, sir.
Yes, sir.
Because of that, you will have a calculation point B. But because of that, you will have a force PS. Di ba? Makuha naman ng force ni mga steel diri. But how about in this case? How are you going to deal with the deflection nga nakaslant? In this case, of course, your bar will experience asa man mo elongate ang imo nga bar. If that is one variation of the problem, asa man mo elongate ang imo nga bar. Obviously, the elongation of your bar will also be something like this. Diba? Diri siya nitaas siya during the pita. So this is the elongation sa imong bar kanang blue. So how are you going to check the vertical movement sa imong nga bar? So this is the total elongation nimo. This is your delta, which is PL over AE. But if the question in the problem is the total deflection at point D, so how are you going to do that? If this is the problem. So determine the total deflection at point D. Obviously, total deflection at point D is, the first deflection is, you just copy this one. This is the deflection. This is the deflection due to your point B. So, nanaog naman na siya. And then the deflection here is the vertical movement of this one. How do you calculate the vertical movements? So, you just calculate this Y. So, how do you calculate that Y? By sine.
Pythagorean.
Theta. Yeah, by Pythagorean theta, you will be able to calculate Y, and then you will be able to calculate the deflection here. So your total deflection at B is just equals to B plus Y. Can you imagine kung sa'yo naitabo sa mga bar? If this is really the system ng naitabo, because your elongation will be along the axis of your member, and this is the elongation, but you have to only the vertical deflection man ang atong gipangita. Can you get class nga nung inana ang atong total deflection at that point? Basta try to think o nga nung inana. And there's also another variation. What could be the variation could also ani? Probably the bars are not of the same length. Like bar AB is mas maba compared sa bar BC. Like this. Like this is your bar. Like this is your bar AB, then probably this is your bar BC, and then probably they are connected like that, and then like that. So I think there's no problem if you encounter something like that. Or pwede po ginana po. Or pwede po ginana. So try to imagine lang kung unsay mahitabo sa imuang nga bar if you will be given a system, something such as like this. So that's everything that I want to kuan sa inyo I want to introduce sa inyo basta I'm really trying to tell you the exam number 3 mostly revolves around this problem. So this is already 3 problems. So me kabaludyon mo nga matag ko 4 problems and this is already 3 problems here. So this is already 3 problems in the exam. So there's one problem obviously wala dire. So that is something you should work on yourself. So but based on that, I think if you try to do it this kind of problems, do it several times with several variations, so I don't think dili mo makapasar sa exam. And anyway, duwa man sad mo, so probably one person will answer 1 and 2 and then the other one will answer 3 to 4, and then if hapit na, let's say at 4 p.m. you combine your answers and then only one will send it. So any questions, class?
Mo turn in ra gyapon tong sir, partner namo.
No. Dili ra usara.
Okay sir, thank you.
Wala ra
Sir.
siya wala ra buhaton tong usa nga partner. So it's either sa inyo ang duwa, but be careful sa katong specific nga format sa pag-send sa inyong file because para di ko maglisod og check og kakinsa ni, let's say for example this is group, this is pair number, pair A, pair B, pair C, so try to check dito kung saan pairing ninyo, and then that is how you format your file name so that when you send it to me kabalo na ko unsa.
Okay sir, thank you sir.
So questions, class? Now sa katong mga wala kanina, so I am telling them that based on the university calendar, the schedule of the final exam is on June 13 to June 18. So we will have an exam on June 4, and then we will have another exam on shared moment diagram on June 18, and then we will have our final exam on June 20. So may nang fresh pa because our discussion is interconnected with one another ramang gyapon. So from the very beginning, the stress, which is the gamit ra gyapon nato ang stress, this one is stress, the force is equals to P over A. So and then we have already discussed of sharing and bearing. I can also include portion of this like for this one in this case yung ko ganina like how many rivets or bolts we're going to use to fasten this one based on that one. So I think you don't need to review a lot because from the very beginning, at least murag nakabalunan mo sa stress, sharing, and bearing. So there's no really problem ng anong dili ta ka-exam on 20 because ang mga questions is just interconnected lang yun. So there's new topic lang yun ani is ang shared moment diagram. And among all this, ang shared moment ang diagram is ang akong pinaka topic because may pinakasayon I think ang pag-imo sa shared moment diagram because same ra gyud na siya ani. Muna nga ako nang siyang introduce lang ng actual diagram because this is most likely what you will see in a shared moment diagram mga inaana lang, and just by looking at figure all the data that you need na dira with just kanang lesser solutions nga inyong ma-introduce. Kay if you going to cut the sections is one, dagan kay mong drawing mo nga free body diagram and then you cut sections ikatulog, so that really takes time, but wala gyud problem if that's how you do it. Both is correct. Ang importante naman is you will be able to establish this kind of relationship here for aluminum, for bronze, or something like that. So in the exam this Saturday, so you will take it by pair. So if you can, if kaya ninyo magkuyog mo sa imong pair, so that's good. but if dili ra po, ayaw ra jud og pamugos. Ayaw man mo agtuon ko ito sa akong classmate kay mag-parent exam. So no, that's not what I mean. And again, the purpose of me having the exam by pair is para kanang naay mukos mo sa inyo is masayop tungod kay nasayop, although the correct solution is correct, but nasayop tungod kay nasayop ang copy sa given, wala na butangan og units, pag type sa calculator is correct, but supposedly the solution is correct. So that is to avoid those type of mistakes. So dapat munang gatagat ang partner para there is this someone nga maka-check sa imong solutions and then something like that. And then sapod sa mga reason mo nang daghan-daghan ka pasayos because malate sila something pag submit sa solution.